Hello everyone, welcome. Welcome to my talk on information models and the future of IFC. So my name is Emma Hooper and I'm Associate Director and Head of R&D at Bryan Digital, where I work as an information manager, either supporting main contractors or clients on projects or within organisations. And I'm also involved with all this other stuff, which includes building Smart UK and Ireland. So having been very much a big technology user and what it seems made a career out of solving interoperability issues, my focus over the past few years has been very much looking at how we can join everything up so that we have less issues in the future. So for this presentation, I was asked to present my thoughts on where I believe IFC will go in the future. So I got really excited because I've been wanting to talk about some of these things for years. So whereas some of the detail is still very sketchy, I believe the overall premise is the direction it will go. But at the end of the day, this is just my opinion, and just because I'm saying it doesn't mean it will happen. And I'm sure there will be plenty of people who probably disagree with me, which is fine. So hopefully this will provide a discussion for the future. And some of the concepts I'm going to be talking about are really a long way off. And coming back to reality, for now, I would just be happy for people to export an IFC model correctly from Revit and get the coordinates right. So I want to start with this slide. I've shown it a few times in the past, and it might be boring, yet it's extremely important. For this session, I want us to forget about BIM, acronyms, pretty 3D models, dashboards, and blingy software that promises to solve everything, and concentrate on this, information. Because it's information which allows us to build and operate everything in the built and natural environment. So what I'm going to talk about is underpinned by my favourite subject, information science, which focuses on the principles, structure and quality of information within a system. And this system could be a capital works project or managing information within an organisation. And sorting this out is what leads to better information management and interoperability within our industry. So in fact, if I could sum up what information and data science looks like in our industry, it is this: a tangled and highly chaotic web of stuff. This is interoperability gone wrong. Incorrect, incomplete and lost information introduces so much risk to projects and organisations, yet for an industry which is obsessed with risk, it's barely ever thought about. And as we create more data, develop new standards, processes and technology and form new initiatives, this beast is growing and getting more tangled by the day. So why is it like this? Well, the first is about poor collaboration, the need to keep appointing more and more organisations on projects to pass on risk or responsibility. You're essentially breaking the information up more and more. And those purposefully benefiting from the chaos and using it to protect interests in an adversarial industry. We need a fundamental change to both business models and procurement. And the second reason, which is what I'm going to focus on today, is having a technology-first approach. Now, you might think that's a bit of a strange thing to say at a technology conference, but please bear with me. I'm not at all saying technology is bad. What I am saying is that since the introduction of CAD software, the language, structure and rules of the software have been the ones used in helping to define the information for the asset, which is often poorly structured and considered. And bring this forward to the era of BIM, and it's only gotten worse. Software applications are tools which process information. They should never be used to define it. The structure and language of information should be defined outside of software, considering the bigger information management picture, and also be neutral and open. And what's more, we're locking information away in bespoke proprietary formats when we need that application to access the data throughout the life of the asset. Data has to live at least as long as the asset. Focusing on technology first has created this point-to-point scenario where data has to be transformed as it is passed on. And this was bad enough when there were only a handful of applications, think back to the days of AutoCAD and MicroStation. But now we have hundreds, which gives us thousands of potential permutations. And there needs to be a longer-term sustainable solution to this interoperability problem. And this starts by focusing on the information by following this simple message. Information should be defined independently of software applications. So what does this mean? We put the information first, so it's the software which serves the information, not the other way around. We open up the information, so we're not limiting which software applications can plug in. And we used a standardised approach, so the data doesn't require so much transforming. So rather than have this point-to-point scenario, we have this. A baseline information layer which spans the asset's life, containing all the structures, rules and language. And to enable interoperability, this needs to be standardised. Therefore, we need to add to this statement. And it's this standardised approach that really helps us to start to untangle the mess we saw earlier. The information within the information layer is complex, and there's no getting around that. It's structured, semi-structured, unstructured, multifaceted, multidimensional, connected in many ways, and the view of it changes according to the use. So to give us any chance of joining this up, we need to use data models. So when you hear the word model, you probably think of this. But I'm talking about what's beneath this, the hidden model, which tells the software how everything is connected. In fact, when I started to think data model, when I heard the word model, it made me think differently, and the whole BIM thing, including the standards, started to make more sense. But what actually is a data model? Well, it can be this, or this, or this. Data models turn what we all know into pure logic for a computer to understand. It organises objects and sets out how they relate to each other. In technology terms, this operates in the back end of a database, which should then have a lovely user interface which people can interact with. So let's go back to the information layer and put it in some context. So we know it provides a consistent language to allow technology to plug in during asset's life, but let's add a management layer and information-based activities for people. And hey presto, you've got information management. Now if we overlay some of the common main standards. So the ISO 19650 series is for the management side. And then in the depths of the information layer, there are many other standards which link together. And there are even others such as GML. But my biggest fear is that as organisations understand the benefits of data models, they will go off and create their own from scratch without realising what is already out there. And if these standards aren't deemed suitable for a good reason, well, that's fine. But anything bespoke needs to be compatible with these standards. And when it comes to data structures being different just for the sake of it, it doesn't necessarily give a competitive advantage. And for the rest of the presentation, I want to focus on this particular standard. And that's ISO 16739, or Industry Foundation Classes, or IFC, which provides the object structure in the information layer. And this is managed by an organisation called Building Smart International. Simply put, IFC is a data specification represented by a standardised data model, which sets out how objects are ordered and how they relate to each other. So I don't have time to go through the basics of IFC in this presentation, but for more information and many other articles, please see the IFC supplement brought to you by Building Smart UK and Ireland as part of the May-June edition of the AEC magazine. So you can either pick up a copy here today or go online. So that was my shameful plug. But I do want to say that IFC is capable of describing all of this, from sensor data for smart buildings to construction programming to work orders to materials. It tries to be all-encompassing, but we're not even scratching the surface yet. So back in the context of the ISO 19650 information management activities, IFC can be used so all processes use the same consistent information layer throughout, from specifying information requirements to in use and, very importantly, checking. The more we can control and standardise the information, the more it can be checked in a more automated, intelligent way against the use cases defined in the information requirements. And this makes exchanging machine-readable information so much more efficient. It's one structure throughout. So let's zoom in on the information layer. At its core is an object-based data model which provides the rules to give everything a unique place and to connect it all up. It contains three important parts: entities, attributes, all linked via relationships. And these entities can cover anything from a door, a system, a whole facility, a task, and even some represent geometry. And then there are some entities which allow us to connect to the outside world. So we can link documentation to objects, and this is really important for connecting the structured and unstructured information. It can link to external databases which contain their own data models and dictionaries for example, product manufacturers' data. And then we can add classifications to give it a local language, basically tagging an object to bridge the gap between people and the IFC data model. So that's the IFC data model in very basic terms. So how do we make use of it? Well, one way is for helping to structure information requirements and acceptance criteria, and this is essentially filtering down the IFC schema specification, so it stays at type level. The second is for structuring the delivered or real-world information to meet those information requirements, and this is at an instance level. So if fire rating was a requirement for a door, in the delivered model, you would receive all doors with their fire rating. And then we simply check the delivered models against the acceptance criteria. And you might think this is a long way off and in the future, but this is really where we should be now, albeit in a more patched up way. So if we look at both scenarios in more detail. So at Bryan Digital, this is the process we undertake on all of our projects, using IFC for information requirements and acceptance criteria. And then this will start to be streamlined in the future, using the information delivery specification concept currently being developed by Building Smart International. So IDS XML is essentially a format to represent information requirements in a data model, which will help automate and join up the requirements, delivery and checking process. And for the delivery side, in ISO 19650 parts 2 and 3, the ultimate outputs are the information models, which are handed over to the client and feed into the wider asset information model. So an information model is defined as geometrical, alphanumerical information and documentation. And currently this is done by packaging the information up into files. Some are structured, many are unstructured, and they're often in different places and they don't talk to each other. But rather than packaging it up in files, within a database, we can connect it all up. And this looks familiar. This looks a bit like IFC. In fact, the IFC delivered models are true information models, which can link geometrical, alphanumerical, and data and documentation. We need to reduce what's locked away in documents and free it as individual structured data. And for me, this is really the premise of BIM. So how does this affect the future of delivery? So currently, we tend to exchange models using step physical format, but this is still a file exchange. So let's try and move away from files to using a proper BIM server, using Delta concepts, where it builds up the connected project information model. And the same idea can be applied to the asset information model. In fact, the asset information model is the real-world response to the information layer. So why aren't we doing this now? Well, we're still very much obsessed with 3D models and how they look. We exchange files, and the mainstream software just isn't there yet. And we focus so much on design authoring tools, but we also need to focus more on the construction and operational phases, and realising that once design is done and traditional design tools have done their job, currently what we're doing is we're going backwards and feeding data back into design tools just so we can write it to IFC. Post-design, we need software which can manipulate the base IFC data, and this is why software such as Blender BIM have so much potential to disrupt. And the asset information model is held in a database, which acts as a store to transfer data into other operational applications. And that store should have governance workflows and be able to track each piece of data. Well, this is really the common data environment. And the beauty of having all this connected data means that it can be queried and visualised in so many ways to give great insight to an organisation, including geometrical representation. So for the last part of this presentation, I want to move more into the future of data and information models. And as I've said, Asset information is multifaceted and extremely interlinked, and I keep showing it like this because that's how I see it in my head. However, most people probably see data like this, in a table, and that's perfectly fine. The problem is that connecting tables in a relational database gets complicated very quickly, especially on a large scale. And when you have tables within tables within tables and hierarchical structures, it's very difficult to join the dots and perform complex querying. Also, many organisations have portfolios of multiple assets, where the data within each asset might need connecting to each other and to other schemas. And that hurts my head thinking about doing this in tables. In fact, I was talking to Tim, one of my Building Smart colleagues, just yesterday, and he was saying that he had real trouble using relational databases when it came to concrete pores and how they connected to spaces and then how that connected to programs. So we need an alternative approach managing this vast connected data, where the relationships are just as important as the entities. So let me introduce graph databases. So when I say graphs, I'm not talking about one of these, but one of these. So a graph is made up of vertices and edges, where the vertices can be thought of as nodes or entities, and the edges relationships. They connect many ideas into a whole, which gives computers a way to understand real-world relationships in a much faster, useful, and complete way compared to relational databases. So don't get me wrong, relational databases still have a time and a place. There are two types of graphs, labelled property graphs and knowledge graphs, and there's a bit of a battle between the two. So deciding which one to use, I think, would be largely dependent on the task, use case, and future developments. The great thing about graphs is that IFC can be represented as one. So this example, IFC has been converted into a labelled property graph and visualised using a product called Graphilion. And this is the entity IFC door and all its connections. But I want to focus on knowledge graphs. So back in 2016, I was first introduced to the concept of the linked semantic data. And at the time, I had no idea what it was, but I thought it could revolutionise information management within the industry, and I've never been able to get it out of my head. So linked data is interlinked data which is structured in such a way that a computer can make sense of the relationships between it and the other data. It does this by looking for patterns in the relationships. You can discover new knowledge that you didn't know was relevant or even existed. So this is a knowledge graph. A knowledge graph is underpinned by a set of standards developed by the World Wide Web Consortium, which create the structure of the graph in a format called RDF. And this links up entities and relationships using a statement called a triple. An ontology, which is a data specification of things and their relationships within a given subject, provides the data model of how the triples should be connected and the unique identifiers. So similar to current CDEs, how the current web works is currently made up of many documents, which we find via URLs. But the data within the documents themselves isn't machine readable or connected. Linked data, on the other hand, forms the basis of the semantic web, where all the data is structured and machine readable via URIs, and can be connected together in many ways, creating a web of data. And knowledge graphs are used in many places on the web, including LinkedIn, Wikipedia, Facebook, but the most famous of all, and where the term first originated, is Google. So if I search for Top Gun Maverick, it brings up lots of information without me having to go into a web page, and this automatically is generated from various sources across the web by using linked data. So it tells me about details of the film, cast, reviews, etc. Or when I ask Google a question, it will answer it outside of a web page. So, for example, where was the 2012 Olympics held? So not only does it tell me the answer is London, it gives me information about London and even how to plan a trip here, which today I don't even think Google will help us with. So how do knowledge graphs apply to what I've been talking about earlier? Well, this is what the asset information model store could be. Organisations would be able to connect this data with data from other assets, other departments, or even other industries. It would take querying to a whole other level and provide really useful answers to help inform decisions. The IFC schema has already been converted into an ontology with formats of RDF, XML, and Turtle. There is also JSON LD in development. And a lot of this has been done by a group called the Link Data in Architecture and Construction Group, which have been around for a while and are doing some really good things. So this is the IFC ontology visualised in a viewer called WebVowl. And I think this is pretty amazing. It's the rules for everything built surrounding us, but in a digital language. So here I've searched for IFC boiler, and then you can see all the connections and how it tracks back up. Now, I know at the start I said I wanted to move away from chaotic and messy information, but the difference here is that this is well organised, connected, and extremely queryable. It's almost like it's alive. So this enables retrieval of information using more complex statements, and this is an app which runs off IFC.js using linked data in the background. In this example, natural language querying has been used to find a random space and an associated door. Imagine asking these types of questions in any standard BIM tools we use now. It would definitely be computer says no. I just feel that there is so much we could do with this way of thinking as an industry, whether it's concentrated onto one task like concrete pours or a knowledge graph for the entire industry. We need to make our data and information work better for us to obtain greater insight and knowledge. We ultimately need to invest in the future of information and be aware that it is the industry's greatest asset. So 5 years ago, I made reference to the fact that the construction industry was bottom with regards to digitisation, even behind fishing. And we probably are still bottom. But this is an opportunity to see what other industries are doing with regards to this way of thinking and learn what works and what doesn't work beforehand. And I'm confident we could then leapfrog up this graph. So in summary, it's very much about an information-first approach and recognising the importance of relationships between data. And I've not mentioned buzzwords like golden thread or digital twins or smart cities, but this does kind of underpin all of that. And this type of work also helps to accelerate machine learning. So I believe information management will evolve into this type of thinking, with graphs playing a big part. And how far we'll take knowledge graphs, who knows? An IFC is not the be-all and end-all, but it is all we have at the moment. And there are other schemas. I mentioned GML, there's Oscar, there's Brick, and it will need to evolve, and it is starting to. So IFC 5 is going to have a new architecture. It's moving away from Express to UML. But whatever happens, I really think the roots to a knowledge-rich future do start with IFC. And when it comes to the information layer, we do need to work together as an industry to improve it, and that means different domains coming together and working with Building Smart. And as I've said, we need to learn from other industries. And then we've got skills. So I think we're really hitting the glass ceiling now with regards to skills in the industry, and we need people with proper training on this. And we also need technology to be developed to plug into that information layer. And the open source movement at the moment is doing some really great work. So I just want to end with this well-known phrase in the world of information science: the future is about things and not strings. So that's me done. Thank you very much.
Thank you so much, Emma. That was a fantastic presentation. It's interesting to look at this in proximity to Greg's presentation upstairs this morning. Having them closer together would have been, I think, helpful to be able to make connections. Do we have any questions in the audience? Quick questions? I will ask a question. So how do we move from the data model that you have and connect it with the existing CAD vendors of today, the Autodesks, the Nemetscheks, the Bentleys, to be able to leverage what you're doing to take the data from a sort of the promise to a future implementation within the existing working tools?
Yeah, I mean, the issue with the software we've got at the moment is it's all proprietary, so it's all built around their own data models for the purpose of the functionality of their software, which is fair enough. So I think, unless you start from scratch, really, then you've always got that transformation. And it's how good that transformation is between the different types of software. Some do it better than others. I've battled a long time with Revit and IFC. It is improving. But then you do have software like Blender BIM, which is written all around IFC, and it's incorporated pretty much the entire schema in it, and it's free. So, that sets a precedent for the future, and I do wonder if, it will start to change the way that we use software.
Fantastic.